Since we talk much about soil health, we are much bothered about the soil health. I'll start with land resource inventorization technology. Friend, this is one of the most important technology that has been developed, and we have been doing it. It is only done in the state of Karnataka in few districts. Now we are expanding it, and this is one of the World Bank supported program. They are now trying to do it on a pilot basis in India, and if it really works, maybe they will extend it to other countries. So in this case, what we are trying to do here, we are getting into a detailed scientific study of morphological, physical, chemical, biological and hydrological properties of the soil, and then we completely digitize the research findings, and then we develop a decision support system, DSS. So this DSS basically guides the farmers to take scientifically sound decisions, right? What crop to grow, when to grow, all those things. And if you look at the solutions to soil and water management, this will also provide survey number wise, farmer wise. It's not a generic recommendation. That is another important aspect. We generate soil atlases. Soil atlas, each atlas, basically we prepare an atlas for one micro watershed which can at least minimum have 500 hectares of land. And then farmers can make use of these atlases. So if you can look at this, this is basically a soil depth. So it talks about the soil depth. If the soil depth is too shallow, or if you take the example of soils in your own campus, these are all lateritic soils. They are very shallow. Their water holding capacity is very poor. So you need to address what are the challenges and how do we overcome them. So this can also be used by the policymakers. We have completely digitized this, and this is available to all people, policymakers in the state of Karnataka. And then we also give it to bankers. Most of the times, farmers go to bankers, take, loan for a crop which is not suitable for their particular land. So this will also guide. When a farmer goes to a bank and asks for a loan, they say your soil is not suitable for X crop. So this is how the land resource inventorization technology is now bringing a revolution in entire natural resource management. In most of the cases, when we talk about DNA testing technology, people always used to attach it to medical sector. But now we have developed some of these tools, basically for testing of soil health. In this case, with the DNA mapping technology, farmers can map their, entire microbial load in their soil, whether they have harmful nematodes, bacteria, viruses, and other pathogens that are present in the soil, and they can take a decision. They can predict and prevent the possible losses that these microorganisms can bring to their crop. So this is a very interesting thing, and if you look at the costs are very less now. It is affordable. Farmers can also make use of this technology. Micro irrigation. Friends, we are aware 70% of the Indian water that is available to us is used by agriculture sector, and this is not sufficient. And if you take the example of Rajasthan, which has highest area under dryland situation, so like that, the most of the water needs to be used meticulously and judiciously. And micro irrigation is one of such techniques. And in this case, this can help farmers to save more than 60 to 70% of the water. So keeping these things in mind, it will not only help in water management, this will also help in getting a consistent good quality yield. Farmers can get it. There will be definitely reduced input cost, because we can also provide fertilizers through the irrigation water, that we call it as a fertigation. And this can also work at a very low water pressure. And then there is improved weed management, because we are not irrigating the entire field. We are trying to irrigate it directly to the root zone of the plants. And then it is adoptable. No leveling is required. You can irrigate it at any elevation. And almost there is zero erosion in this case. And you can also have chemigation, fertigation, fumigation, all those things can be done through micro irrigation. Micro irrigation has revolutionized Indian horticulture, I should say. And now we are trying to extend it to other regular crops. If you take vertical farming technology, so especially around cities, big cities, so it's a practice of growing crops in the shelves, which are stacked one above the other. And wherever we have issues with the land, or especially in the cities, we don't have much land available for production of crops. In those cases, we can make use of this. And basically it is associated with technologies such as soilless technologies. We can make use of hydroponics. We can make use of aeroponics, things like that. I will come to those techniques later. In this case, the water which is rich in nutrients is just circulated to the plants, and where the roots of the plants are dwindling. So, in case if there is less sunlight or more sunlight, if it is less sunlight, we make use of LED lights. If it is more sunlight, we increase the shade net. So that is the situation. And these farms can also reduce the water to the tune of 70%. Means the water saving is very, very high. So if you look at the labor requirement, this can be completely mechanized. So this is now becoming a very famous technology, especially around the cities. For mechanization and automation. So if you look at the small sizes of the farms, for example, if you take the average Indian farm, it is 1.08 hectares. 83% of the Indian farmers are small and marginal, and we have small land holdings. So any of the technology that we're talking about should also address the constraints and problems faced by the small and marginal farmers. Keeping that in mind, see, the small farmer cannot have 2 pairs of bullocks. He cannot keep 1 tractor and all that. We are now talking about custom hiring mechanisms. So keeping those things in mind, farm mechanization has become an inevitable solution or option for all of us, and automation is one such situation. So in this case, we are trying to apply all smart farming mechanisms which are more efficient. They will help the farmers to complete the crop operations in a very limited window. And automation, basically we make use of drones here. We make use of automated tractors. We have driverless tractors. You can just feed and guide, it will go and do the operations. And then we have robots for seeding. Exact seeding, space you adjust, it will go and seed exactly at that spot. And then we have automated watering, automated harvesting. We have such a wonderful robotic technology that's available. It will go and identify only the mature fruit and pick it. And we have, for example, you have areca nut. Areca nut is one of the most important crop here. And climbing or harvesting the areca nut is a very tough task. Under such circumstances, robotics can be one such technology. So entire mechanization and automation is possible, because in the days to come, we will further have a lot of labor related issues. So automation is one important technique. So in this case, irrigation is automated. As and when in the fall, in the moisture stress, automatically it will irrigate. And harvest automation, it will regulate and it will identify the matured fruits or whatever it is. And then we have weeding also. So all these things are part of automation and mechanization. Greenhouse technology, basically we talk about protected cultivation. So this brings a lot of advantages to the farmers. Basically it is an emerging technology and it is being adopted in large scales. If you go to countries like Vietnam, if you go to countries like Israel, it's only the green technology and the greenhouse technology that they are using. And though it is capital intensive, there are a lot of support mechanisms available from the government. Farmers can make use of it. And if you look at the resource efficiency, whether it is seed, fertilizer, water, it's very high. And you can grow all types of fruits, vegetables, flower crops. This is possible. And if you look at the modern greenhouses, they are becoming increasingly textile. Earlier we used to just construct a greenhouse and then produce something inside. Now it is completely automatic. If there is a shortage of light, we make use of LEDs. We also cover them with solar panels. The entire greenhouse, the energy required for the greenhouse is produced there only. All those things are happening. And there is no season round production. You can produce the crop throughout the year. And yields are high, quality is very superior, and this will protect your crops from all adverse weather conditions. So this is a controlled environment, and you can control all production factors, including all climatic factors. So this is one of the important innovative technology that is really revolutionizing horticulture. Shade house technology, especially in those areas where the harsh sun, strong winds, they are the problems. In that case, we go for shade house technology to bring down the intensity of light. In this case, you can also conserve water. It brings all the advantages of greenhouse for what I explained to you earlier. But you can have extended growing seasons. If you take, places like Uttar Pradesh and all, we will not be able to produce the crop throughout the year. But people with shade house technology, they can produce vegetables, flowers, and short duration crops in these shade houses throughout the year. Precision horticulture. So this is now, post 2015, we started talking about precision horticulture. In this case, we make use of several technologies. We talk about geographical positioning system, we talk about GIS, we talk about auto steering of the equipment, we talk about variable rate application, we talk about sensors, we talk about environmental sensors, crop sensors, soil sensors, moisture sensors, all those things can be used here. And we are also making use of drones and satellites because we try to get the aerial imageries of the crops and basically to detect the stress, to detect the pest and disease outbreaks, and also to monitor the entire crop growth and performance. So precision horticulture, in this case, we are very precisely applying inputs. I am talking about variable rate application. Basically, VRT, variable rate technology. For example, soil is such a diverse material. You don't know where it is nutrient rich, where it is nutrient deficient. So entire sensor system will identify. For example, a small patch of land is rich with nutrients. When the application comes, it will reduce the application of nutrients there. Wherever they are deficient, it will apply more. So we call that as variable rate technology. So that we have. So we get the entire data analysis. We get the data, we can assess it, and we can process the data. We can get the insights how the field is varying with regard to nutrients and other aspects. And then we also make use of robotics and automation. Basically, all operations are done with very high precision. So that is the beauty of precision horticulture. So quality is very high. Again, better decision making, no delay in taking decisions, and all the control mechanisms are operated, and this is possible intensively. Basically it has more cost thing to start with. Maybe in the later stages this will also come down. Blockchain technology. So now people are becoming more conscious. People want very high quality food. People would like to know from where the food is produced, or whenever there are problems associated with food. We talk about food poisoning, we talk about diseases that are spreading because of the food. Under all such circumstances, blockchain is a beautifully decentralized structure where we can trace the crop right from row to plate, from the soil to plate till it comes to your plate. So this is actually trying to bring all the transactions. For example, even people want to do international transactions of the food that they have produced, they can make use of the blockchain technology. When people are very much worried about the quality aspects, blockchain technology can be used. It can trace back to the field from where the food has been produced. And if you look at the foodborne diseases, which basically threaten the public health, under such circumstances, the first step in root cause analysis can be through blockchain technology. So it's basically a very interesting technology wherein you can identify the food that you are eating has come from what field. So this is making a lot of revolution, especially with regard to quality of food, especially the export demands are more with those crops which are using blockchain technology. AI. AI is the talk of the day. People are talking about AI. Agriculture, people did not talk much about AI all these days. But now, and if you look at the entire rise in the digital agriculture, this has opened up a wealth of new data, insights, opportunities. And in this case, by making use of the artificial intelligence, we can monitor the crop 24/7. And we have different technologies. For example, we have remote sensing, we have algorithms. They will help in processing the data, helping or guiding the farmers in decision making. So this is happening. Especially farmers, they can make use of AI for taking decisions, whether it is application of inputs, whether it is harvest time, whether it is prediction of the yield, or the actual harvest of the crop. So all sectors, right from seed to harvest, AI can be used in horticulture. So this is again revolutionizing. It is not just for monitoring of the crop health or plant health or the soil health. It is basically to understand the deficiencies that can affect the crop production. So this is a very important AI application that is happening in horticulture sector. Insect trapping. Now people have become more cautious. People don't want to eat that food which is produced with more chemical applied and all that. So in this case, we also talk about local technologies, but which have a scientific touch. In that case, insect trapping technology. In this case, what we produce, what we do, these are the traps. We call them as insect traps. You can see the small bulge. In that case, we put that pheromone. It releases smell like a female insect. All the insects, they get attracted, they come and fall into it. This is very simple technology. So, instead of eating crops, they get attracted, they come and get stuck into that system. So, we have different technologies here. We have a bright yellow and blue colored recyclable sheets, of wavelengths between 500 nanometer to 600 nanometer, which have a capacity to attract and trap at least 19 pests, which are classified as very high risk pests. So they can attract. And this is a very simple technology. They can attract insects from a long distance. So that is the beauty of insect traps. So we are trying to eliminate the spray of chemical pesticides here. Breeding high-yielding varieties. Especially post-independence, we had a lot of issues with the food production. We had shortage of food, people were suffering. But now, the entire focus is on biofortification. In spite of several revolutionary innovations in agriculture, horticulture, we still find nutrient deficiency, especially in women and in the children. So keeping those things in mind, the entire focus is now on to breed for stronger crop varieties, which are biofortified. For example, we can make use of zinc fortification, iron fortification. You provide these essential nutrients in the crop itself. So that is the beauty of biofortification. As we are all aware, that nutrient diet is vital for the production, for the good strong human health. So as healthy people will never have diseases. They will, besides maintaining their body strength and all. So keeping those things in mind, how do we ensure that the energy, protein, essential fats, vitamins, all those antioxidants are provided through the food? So this is one important such technology which will really, bring a significant change in enriching the nutrients through the food. High density planting. We have two things here. One is high density, and then we also have ultra high density planting, reducing the planting distance. So that's a very interesting thing. High density and ultra high density, basically it's a revolutionary shift in the orchard establishment. This is very relevant for Kerala because Kerala has a lot of orchards, and we are trying to make use of the land to maximum extent. This is the beauty. And then we also accelerate the productivity for unit area and reducing the gestation period. For example, if you plant a cashew, you at least have to wait for 2 or 3 years as a gestation period. When we go with this, there is a possibility because we go for advanced training and pruning technologies that will also reduce the gestation period. And then we can also make use of both vertical as well as horizontal space utilization. We are trying to plant the trees in a very close spacing. So this will also optimize the sunlight interception. This will also reduce the gestation period, facilitate mechanized management if possible, and early returns on the investment. This is very important. People don't want to wait for a long time to receive the inputs. So this is becoming more and more popular, especially in the fruit crops. We are now advocating this. Tissue culture technology. In this case, tissue culture, it is one of the most critical biotechnology, and which is helping the farmers, and the scientists to produce the elite varieties which are free from diseases and pests, which are, you can also produce the plants from the preserved germplasm. All these things are happening. And then, if you look at the growth of India's tissue culture in the last few years, is about 15% per annum. The plants produced through tissue culture is increasing. It brings several of the advantages to the farmers. One is biological advantages. We are getting plants which are free from pests and diseases. We are getting true to type plants. There is no changes in that. And then we are also looking at faster multiplication, and then year-round availability. Tissue culture can provide plants to farmers throughout the year. And then we also have certain economic advantages. One is rapid availability. You place the order, you get the plant. And then reduced cost per plant because we are producing it in a huge mass. And then premium pricing for certified. This is free plants, and then reduced vulnerability. This is most of the important aspect. For example, if you take pomegranate. Pomegranate is one of the most important fruit crops. This is dollar or pink crop, we call it. And it has several, pests and diseases attracting it. So one such is the bacterial plant. So through tissue culture, it is possible to produce a disease-free plant. So that is how, in such cases, tissue culture is bringing a revolution in improving overall horticultural productivity. Generating fresh water with solar technology. Though it is not very popular in the Indian continent, but this is going to happen because especially people who are closer to coastal areas. So you can make use of this technology, and you can also, scarcity of fresh water wherever it is, you can make use of this technology. Earlier, the stumbling block with this technology was a high cost, and now this is coming down. People can make use of the salt water, purify it and then apply it. And especially when they are using the growth houses, they can make use of very little water. But if you take countries like Israel, there, that is the only source of 3D farming, 3-dimensional farming. So, if you look at this, we have very interesting technology which is now becoming popular in bigger cities like Bangalore. Slowly it is picking up. It is not that popular as of now in the Indian context, but this is now picking up. So in this case, we are making use of a 3-dimensional production pots, and they are repeatable structures. They can be reused. You can have your own modular design, and then you can take it from one place to other place. It can be a plug-and-play design, and you can place them in the greenhouses and under completely controlled conditions. You can also produce customized based different types, and it drastically reduces the water usage. This is another interesting thing, and you can make use of all the latest technologies like AI sensors and all that, and you can plant any of your vegetables in a very high density way, and this is the thing. And if you look at the benefits, it brings a lot of benefits. One is local food production. This is possible. You need not have to transport food from a long distance, and you can also customize to the local demand. For example, something is essential or something has more demand in Kasaragod. Only that can be produced through 3D technology. And then you can maximize the production because you can make use of all the few techniques that we have discussed up here. you can move your entire horticulture zone from farming to edge. Basically, the best technologies and innovations in horticulture can be combined here. You can bring down the cost of infrastructure that is required, and you can also customize the pods to the requirements, and you can bring down the wastage of inputs basically, and lot of transport related costs can be completely reduced, and AI driven monitoring is possible, and reuse of resources. The same water can be recycled several times. So this is now becoming more and more popular, and this is highly popular in countries like US. Now we are trying to redo it for Indian conditions. Eco-friendly features. Now we are talking about organic farming. We are trying to optimize the plant production. Basically, the idea is to bring down the water usage. Most of us consume only rice. The amount of rice, the amount of water that rice consumes, anywhere between 1,500 to 3,000 liters to produce 1 kg of rice. And how do we bring down this? So that is very important. And how do we recycle the material? This is one of the cyclic agriculture we talk about. And then pollination, optimization of fertilizers or nutrients, that whatever you are using, and per cubic feet you can produce more, and the infrastructure cost can be drastically brought down. And with local universities can definitely make use of such technologies, train the farmers, give it to them, and you can also whether it is application of nutrients, whether it's application of pesticides or chemical friendly, environmental friendly pesticides, all can be mechanized. It means the variety of advantages are afforded, are given to the farmers, and people have to now focus on this. Weather forecasting technology. I would like to quote an example from Karnataka. We have Karnataka State Natural Disaster Management Center, which is one of the world's largest weather monitoring agri-distribution organization. Every 7 kilometers we have a weather monitoring station, a weather recording station in there. And there they can give the prediction for 15 minutes, 30 minutes, 1 hour, 3 hours, half a day, 1 day, 3 days, 15 days, 1 week, 15 days, and 3 months predictions can be given. It means, for example, we have weather forecast, we have crop insurance, agri-risk management advice. For example, we have lot of grapes producing farmers in the northern part of Karnataka. If there are going to be hailstorms, they will give a quick advice to them. They will cover their crops. Otherwise, they will lose their entire So like this, the prediction of weather patterns has become more friendly, more helpful. This technology was not available earlier. Now, the entire country is looking at this technology. Now they are trying to see how other states can repeat this model for predicting and advising the farmers with regard to vagaries of climatic factors. We have soilless farming, hydroponics. You must have heard about hydroponics now. And basically this is a system of producing high value crops without soil. In this case, we are trying to make use of a water solution which is rich in nutrients, and we can make use of an inert medium like perlite or cocoa. Here, the conservation of water is to the tune of 90% because the same water is recycled. You are just trying to enrich it with nutrients as that when nutrients are taken up by the plants. Then it is possible to enhance the rate of growth, faster growth and high yields are possible again. Reduce the pesticide use because we are doing it in a very controlled condition. The pest and disease are very less. And we also, year-round production is also possible. And then we have aeroponics. In this case, nutrient-dense water is sprayed to the root zone directly and you can produce. And we have aquaponics, wherein fish which produces its excreta is used by the plants and the water is purified and recycled for the plant growth. And then we have certain integrated pest management and organic technology where we make use of cultural practices, biological practices, to manage the crop pests. And then we have FPOs, farmer producer organization is one of the wonderful institutional mechanism to collectivize small and marginal farmers to address the challenges that they are facing in both supply and market chains. And then we have ENAM. ENAM is one of the most innovative marketing platform in the country, wherein the entire operations of markets are done through an online platform. And again, we started it from Karnataka. Now it is now spread across the entire country. So we are now talking about digital integration and IoT applications in horticulture. In this case, as of now, we have developed digital soil health cards which are linked through Aadhaar. We are trying to integrate with the Kisan call centers so that each farmer gets a specific advisory. And now we are trying to monitor the crop through completely satellite based. But the technology deployed already is basically normalized difference vegetation index that is possible. And then we also have multispectral imaging and thermal imaging and GPS technology which is already applied in the field. And now we are trying to look at yield prediction models, and then we are also looking at the irrigation scheduling optimization. Those things are now happening at the field level. Future vision, we have to now focus more on precision autonomy, climate resilience, value addition, integration of digital technologies in agriculture, horticulture, inclusivity, sustainability and nutrition security. These are the focus areas for immediate future in horticulture sector. And finally, the path forward. There is a need for sustained public investment in research, infrastructure and extension. The strategic partnership with the public and private sector institutions. We have to also bring the farmers' participation in any of our policies. They keep the farmers outside. And then continuous technological innovations are required. So that have to be aligned with the ground level realities. Most of our research is academic. It should not be academic. It should be need based. And then attention to integrating the local technologies, the integrating, bringing the IKS into horticulture, and then innovations that are there to be made use of in the future generations. Thank you.
Thank you, sir, for your nice, informative and thought-provoking lecture. So I'm sure that the students and research scholars are beneficial from his talk. He has covered almost every area in horticulture, and the innovative techniques also he mentioned. Sir, I would like to just ask one question. So you mentioned we have the population is high in India, and we have limited land space. So how will you feel in the next 20 years? What are the challenges you face in this area, in horticulture? How will you feed this increase in population?
So a very interesting question. If you look at this, answer for this question is the integration of all the technologies that I have presented, because most of them are suitable for small and marginal farmers. If you look at the Indian, agricultural landscape, 80 to 83% of the farmers are small and marginal farmers. And one of the NSU studies very clearly brings out the fact that given an opportunity to these small and marginal farmers, they want to get out of agriculture and they look for some other alternative livelihoods. So keeping those things in mind, it is important for the Indian agriculture system to retain the small and marginal farmers in agriculture sector, because we have to feed 140 crores of people. These small farmers, they produce 50% of the food requirement in this country. So it is technology which is farmer friendly, which is easy to adopt, which is cost effective, only can save the Indian agriculture or horticulture system.
Adding to that, sir, how India is going to support such a marginal farmers for infrastructure for this kind of technology supporting farming?
I touched upon, because paucity of time I just rushed. I touched upon one institutional mechanism called farmer producer organizations. Basically, individual farmer cannot bring all the technology on his own to the farm, because he or she holds a very small size of the land. So FPO is one institutional mechanism. It's an innovative institutional model wherein it will notionally amalgamate the land holdings by bringing small and marginal farmers under the institutional fold. So they can produce a similar crop, they can have access to technology, they can have access to inputs, they can have access to markets, they can develop common facilities. For example, whether it's a storage facility, processing facility, pre-processing facility, all can be developed for a group of farmers. That is the only solution that we can have. Individually, we will not be able to do this. So, through such an institutional mechanism, we can address these aspects of the rural.
But to farmer producing organization, if it is with the government, then it will be more facilitating to the farmers, marginal farmers. If it is privatized, then again the farmers will be, I think, they will get affected on that.
No, it's a very interesting
It's
question.
my-
I would like to just clarify. Farmer producer organizations are those institutions wherein it is only farmers for the members. They become members of these institutions through their share capital. Neither the government nor the private institutions can have partnership with this. So, whether it is decision making, whether it is any of the initiatives, it is only through them. They are managed by them, they are owned by them, they are governed by them. They are only facilitated by the government, and they don't have any stake of the government or a private sector. So, private sectors cannot hijack the farmer producer organizations. So that is the beauty of this act, because they started thinking about this in 2002. Finally, we came out with an institutional solution in 2013 by amending the Companies Act. So there is no threat.
Any question from audience?
Discussing about the vertical rate technology. So in a larger area, how to identify a small patches of feed with the deficiency of any nutrient?
That's a very interesting question you are asking. You know, we have developed sensors. No, we call them as soil sensors and moisture sensors, things like that. Since the diversity of fertility is very high, soil here is different, next 10 feet is different. So it's very difficult to collect and sample, analyze each sample. These sensors have a capacity to identify, which soil, the portion of a soil that is deficient in X nutrient, Y nutrient, and that will feed that into a system. So when the variable rate technology mechanism comes, so if the soil is rich in nitrogen, this will not apply nitrogen flat area. It will stop. It will apply only those deficient nutrients, and then it will move to the next crop. So that's the beauty of variable rate technology.
In that case, these technology or the sensors, what you are using, it will not affect the microbiome.
No, this will not have any impact on the microbiota, microbial load in the soil. It will not affect it. It is only to identify.
Okay. Another general question, sir. Usually, margin farmers usually go for a normal cropping, not the free cash crops. Where, as per your, technology is conceived, either margin farmers are really affordable to.
If you take the example, yes, I'll come to you. If you take the example of the greenhouse technology, CO2 technology, the government of India through National Horticulture Board and National Horticulture Mission is giving subsidy to the tune of 25 lakhs to the small and marginal farmers with 2 hectares, 3 hectares, 4 hectares of land to establish them. Lot of farmers around the cities in Bangalore, bigger cities in Karnataka, even cities like Trivandrum and all, now they are making use of this. They are producing and they are selling. Especially floriculture has become a very popular crop to be produced under controlled conditions. This is possible. Farmers have to accept this. These are designed both for big farms as well as small farms.
Good morning, sir. Sir, if we have to take up horticulture as entrepreneurship opportunity, how to proceed with it?
Oh, wonderful question. See, we have lot of incubators which are talking about it. There is one scheme of the Indian Council of Agricultural Research which is promoting technology incubation centers, centers in the universities. And this is possible. See, you have a lot of opportunities for starting your own startup. There's a funding available for horticulture startups. If you are talking about producing an export quality flowers, export quality vegetables, you can think of it. You need not be completely new in your ideas, but this is possible. There are technology incubators, there are business incubators in most of the agricultural universities, and for example, Kerala Agriculture University (KAU) also has a such mechanism. I believe that, right? Yes. So they will guide you, and in case you need any more information, right? So because I was part of your education summit in Kerala 2 years back. Your Honorable CM had invited. So there it was only for the students of agriculture. So there were such 10 questions that came, and we had requested the people to create an incubator for the benefit of students. We want students to become entrepreneurs, not just job holders.
Okay, since okay.
So we have so much technologies and innovations, but myself and Mrs. Corin Pencils. Since we have many technologies and innovations, I wonder how much of this is reached to the farmers or commercial farmers. So do you think that we need more awareness among the farmers so that they will know about these innovations, the support system, and doesn't the government need to support them?
Definitely, see, government is responsible for everything. The technologies that are developed in the laboratories of the institutions, universities, research institutions, ultimately they have to reach the farm. And if you fail to take the technology from laboratory to the land, there is no point in developing any such technologies. So most of the technologies that I have touched here, except few. I mean, for example, a solar, water conversion and all that, we are not using it. But these are all available. All farmers are aware. And, there's a mechanism to spread the technology. We have now applications, we have technology applications, mobile applications. You just name it, it is available to you. And each of the farm universities in the country, we have 75 plus agricultural universities across the nation. And all of them will have one wing called Extension Education Units, wings. They are actually meant for taking the technologies from the universities to the farmers' fields. None of the other universities will have this mechanism. We will have only academics as research. Whereas agricultural universities in Karnataka or in any state of the country, they have a system called extension. The purpose of extension is to take the technologies developed in the laboratories to the farmers' fields. Right? This is all. Any other questions?
So,
Yeah.
good morning, sir. Myself, Dada. I have a few basic questions about this horticulture. First is high-density farming. So, is it relevant, or can we claim that in high-density farming, each crop can give the same as that of a particular plant that is growing in a normal condition?
Very interesting question you asked. See, in this case, in case of ultra density or high density planting, we are trying to reduce the space provided for each plant. For example, if you take the example of mango, or if you take the example of pomegranate, right? We used to plant a mango at a distance of 40 feet by 40 feet. Then we came down to 35, 30, 20. Even at high density planting, we are planting them at a distance of 12 or 15. So here the number of trees that we are planting will be high. The yield per plant may come down, but the number of plants per unit area is high. Automatically that will enhance the overall productivity. That is one. And the second thing is we are trying to harness both vertically as well as horizontally the space and the light, which is not the case. In case of normal planting, there is a lot of space that is wasted in between. So that is the beauty. I mean, here we have a technology to train the plants, prune the plants. If you take example of mango, mango bears fruits only on the new shoots. Or if you take the example of drumstick, drumstick cannot bear fruits on the old twigs. You have to train it, prune it. So for drumstick also, you can make use of this high density technology. Number of plants per unit space is more, and you can produce definitely 1.5 to 2 times more than what you were producing in a normal planting distance.
So again, when it comes to high density cropping, the ratio of getting diseases or pests is more compared to that of a normal growing technology.
We cannot say that. So whether you have a single plant or 10 plants, the disease will be a disease. It will come. But in this case, as I mentioned to you, you can mechanize it. You can mechanize it when it comes to spraying or taking plant protection measures or taking integrated pest management products. So it is not just because of the high density, the pests are more. The pest load may be more, but it is possible to. We have technology to monitor. Because of time paucity, I rushed. I was talking to you about integrated pest management, IPM technologies, which talks about managing the pests in a production system, whether it is biological management, chemical management, physical management, cultural management, all those things. It's a combination of all these factors which can be applied to a particular high density production area to monitor or manage the pests.
Okay, thank you very much. So I think we can have a question during tea time. So with this we will conclude this plenary lecture. Since we are here, the plenary lecture was highly informative and it was very useful application aspect of plant science. That's why our students are more interested and keen on attention showing while you presented. And they have a lot of questions to ask. I think so. During tea time, we can interact with our Honorable Vice Chancellor. Here today, we have witnessing the lecture our Honorable Vice Chancellor. I request Honorable Vice Chancellor, our Vice Chancellor, join with us to give memento to our plenary lecture. Please, sir.
Yes. Thank you. We are also fortunate that we are really
Good comment. A lot of questions. In most of the institutions, students do not ask questions. No, that's very interesting.